So if all of the elements in the universe, except for hydrogen, okay, were created in stars, that means that all of the elements on Earth and all the planets were created in stars. And what you see, very good evidence for that, is that from the spectral lines in the sun, I told you in the last video, we can get an estimate of the composition, the elemental composition of the sun. And we can measure on Earth the composition of the elements in the Earth's crust. And if you do that, you see something very interesting, which is that the general trends here are the same. And this makes sense. I mean, the Earth was formed from star dust, right? So it makes sense that the Earth has similar composition as the sun. Okay, so but the main trend here is these are, by the way, a logarithmic scale. Be careful about logarithmic scale, right? So from 10 to 0 to 10 to minus 3, that's a factor of 1,000 less we're going here. This is a slightly different scale, but you could do the same thing here. It's still logarithmic, so you could go, these are different units, but it doesn't matter. 10 to the minus 2 to 1, right? That'd be a factor of 10 to 1,000 more. But you see that the heavier elements are less abundant in general. That's the first trend that you can see, right? And that's true both in the sun and the Earth. Makes sense because you had to have more processes occur to make those more make those heavier elements. More fusion had to occur. More neutron capture events had to occur, right, to build up to, let's say, uranium, right? The other thing that you'll notice is that hydrogen is very abundant in the sun, and so is helium. But if you look in the crust, hydrogen and helium aren't particularly abundant. In fact, helium is very rare. Okay, there's certain pockets of it that get formed. And why is this? Well, hydrogen and helium are so light, right? They're gases. They escape. Most of it Earth formed, and then a lot of it just escaped. Gravity of the Earth couldn't pull in hydrogen and helium. If you look at the composition of like a bigger planet like Jupiter, it's going to have a lot more hydrogen and helium. It's going to be a lot more closer to actually this composition of the sun because bigger gravity pulled in the hydrogen and helium. The last sort of interesting thing about this plot here on the right of, well, both of these actually show up, but it's clear here because it has these lines for the Earth's crust, is you see a lot of like up and downs, right? And look particularly at the rare Earth elements. These are F block elements starting with lanthanum, cerium, praseodymium, neodymium. If you look, it's going up, down, up, down, up, down, up, down, right? Why is that? It turns out that if you look at the nuclear physics behind this, the elements with an odd number of protons are less stable than the elements with an even number of protons. So for this reason, you see this oscillation, okay, in the crustal abundance of elements, generally speaking, when you go from odd to even, odd to even. So you march across the periodic table, you're going to have these oscillations. So that's pretty interesting.